paid for IP, and so therefore I'm not really allowed to share this. This is the same practice exam that, you know, when you book your exam, it asks you, do you want to buy a practice exam? This is the practice exam that you can buy. And I think it's really, really good. It's what I use to prep for all of my exams. This specific provider. But yeah, obviously, because it's a paid for tool, I cannot put it on the public internet, but I will record it and I will make a private link so that people in our little learning cohort can rewatch it afterwards if they want to. So yeah, but just don't be sharing it with other people publicly, is my ask. Otherwise, I'm going to get in trouble. um, we're just going to go through questions, and I will sort them by topic. So you see, these are the topics that come up in the DP 100 exam. And we'll start by looking at the Setup Azure Machine Learning Workspace. We'll look at, I guess, maybe 4 or 5 questions from this section, and then we'll go on and do the others, because I find that whenever I do this kind of session, I always end up doing a lot of questions in the first section, and then I don't have time to do any from the last section. So we'll try and keep on time for that. Okay. If you could all watch out for anyone else wanting to join and click on the admit, because as you see, I'm like looking over here to see to see whether people join, whereas I have the exam on this screen. Okay, here we go. You can also, if you want to put questions in chat or answers in chat, you can. That doesn't show up on the recording. The chat doesn't show on the recording. So if you are shy, you definitely put your questions in there. However, there's only a few of us, so feel free to shout out questions or answers. It's more fun, I think, if people shout out answers, and then we will see where you are, whether you are confident or not. Okay, let's go. Let's see. What I like about this as well is it gives you an idea as to what the exam questions look like in case you have never sat one of the exams before. Okay, now in the exam, this type of question appears in the associate and expert exams, but not in the fundamentals. And they are in a set of 3 or 4 or 5 questions. And you can't go back to review these questions in the actual exam. So normally I would say to you, the best practice is go through, answer all the questions as quickly as you can, and then mark for review with this little star here, or I think it might be a tick box in the exam that says review. Mark for review the ones that you weren't sure of, so you can come back later and change them. But in the exam, these 3 questions, these kind of set questions, you can't come back to them afterwards. And the reason is, generally, once you have seen all of the answers to all 3 of those questions, you know which ones are right and which ones are wrong. You can kind of rule them out by process of elimination. Okay, so let's do this one. You configure an Azure machine learning workspace for your organization. Your organization wants to leverage the platform for additional machine learning projects. You need to create a compute instance that would support running machine learning pipeline training using the Azure Machine Learning Designer. Solution, you create a machine learning compute cluster. Does this solution meet the goal? Anyone want to shout out? So Ada, what's your guess?
I think it's no. I don't think it's sufficient to have any. Just want to leverage.
I think it's yes.
I think it's yes.
I think it's yes.
Let's see. It is yes. Here we go. With machine learning compute cluster, you can easily create a single or multi-node compute instance. With machine learning compute cluster is the only type supported by Azure Machine Learning Studio to associate a machine learning designer training pipeline. So you need to know the difference between compute clusters, compute instances, where you can use them. So in machine learning workspaces, in Designer, in all of that kind of stuff, you need to know where you can use what and what does what. So same question, you create an Azure Databricks environment. What's the answer?
No.
No.
Yeah, definitely no. Because, well, that's very fancy and we like that. It does not meet the goal. So it's an Apache Spark-based environment in the Azure cloud. It can be used as a target for the Azure Machine Learning pipeline, but you cannot set it as a target in the Azure Machine Learning Designer. 3, you create an Azure HD Insight environment.
No.
Also no, right?
Yeah.
HD Insight is a platform for big data analytics. It provides Apache Spark, which can be used to train your model, but you cannot set it as a target in Azure Machine Learning Designer. Cool. Okay, this is tick box 1, and we need to pick 3 actions from here that are going to work. I would say always go right the way down to check that you can see all the answers. And which ones do we want? So manually define security rules to isolate your Azure Machine Learning training processes within an Azure virtual network. Need to ensure only required communications from the internet are allowed. What 3 actions are we having?
The last one, define inbound security rule. Ensure the source service tag is set to batch node management. And the third option, ensure the source service tag is set to Azure Machine Learning. Those are my picks.
I think that it's this one or this one. Do you want the source service tag to be batch node management, or do you want it to be Azure Machine Learning?
Azure Machine Learning will do.
We are choosing 3, right?
We're choosing 3.
Yeah.
But I think you can rule one of these out because it's the other one. And
Okay.
then I think you want one of these 2, either to configure the source port range or the destination port range.
Oh, yeah, maybe. Yeah, probably.
Probably
That one. Yeah.
Probably this one. Let's see. There we go.
Yeah.
There we go. So, inbound security rule, because Azure Virtual Network serves security boundaries between resources and the internet, and you can control inbound and outbound to and from the Azure Virtual Network by defining security roles that act like network firewall rules. To ensure only required communications from the internet are allowed, you define an inbound rule. Then you should ensure the source service tag is set to batch node management. Security rules include an option to identify groups of Azure Cloud resource nodes using service tags. This allows you to define security rules without having to manually identify the IP address of the Azure resources. I'm tired of reading already. And the third one, the batch node management service tag, is in that destination port range. So you need to have a rough idea as to what the destination port ranges are for these kind of things. The source service tag is not set to Azure Machine Learning because that is only required if you use Azure-based compute targets. If you're using your own compute targets, then the service tag is not required. Port 22 is SSH, and we don't want an outbound rule because we don't care about going out. In this scenario, we're controlling what comes in. Tools. I'm going to look for a different type of question. Drag and drop. Although I might go further on, actually. Let's do that. No, let's not do that. Let's go further on, because I always spend a lot of time in the early questions. Let's go further on and make sure we're looking at questions that you might not have seen before. Okay. Here is a drag and drop one. Ooh, look at that. 6 actions in sequence. Ooh, from a really long list. But definitely, you do not have a list that long in a fundamentals exam, and you don't have to pick 6 of them. Normally, you have to pick 3. So you know you're in the harder exams now. Ooh, this is hard because can I fit more on the screen? I think make it a little bit smaller. Can you still read that if it's like that?
Yeah.
Okay.
I think I can read that.
Okay, so an e-commerce company wants you to create a machine learning model that runs classification algorithm on images that they receive from various product vendors. The model will be used to categorize these images into product labels based on what the image shows. You decide to use Azure Machine Learning Studio to create a labeling project for an initial set of images produced. You create an Azure Machine Learning workspace in an Azure subscription. You're now ready to create the labeling process. So an image can only be given one label during the classification process. The labels that are associated with the products do not change. To reduce errors, you want all the labeling to be done manually. Additional images will need to be added to the data store on a weekly basis. Ooh. Okay. So some of these you can see it's either this one or it's that one. So when we want an image can be given only one label. Are we wanting it to be multi-label or multi-class? Those would be the 2 options of which we're ruling one out, right? Shraddha?
I would say multi-class.
I would say multi-class. Okay. I think maybe we want to provide instructions. Do we want the incremental refresh turned on or off?
Yes, on.
On.
Mhm. Oh, do we want to enable machine learning assisted labeling? Do we want that off or on?
Off.
Off.
Yeah, that is one.
This one?
Yeah.
We need 6 actions, so
Yeah, it's 6 actions.
And then we want one more.
I think the first one. I think the first one in the proposed action as well.
Yeah. Okay, so we have 6 now. And what is the order that we put them in? Does anyone have a good idea what is the order?
For memory, you need to set up the storage first before you can set up your class.
Yeah, I think select or create a sequence first. And then it will be create the list of label classes.
So here.
Yep. Then provide any instructions for the labelers on the process of classification.
Okay, let's see it. Okay, so it says choose image classification as the first one. So that we had much. Down here, this is number 1. Number 2, select or create data set. Okay, yeah. Then ensure incremental refresh is turned on. Then the label classes, then instructions, then that. Let's look at its reasoning. So first, select image classification multi-class as a task type. You want all images to have one label and to be classified based on label class. Then you need to select or create the data set of images. Then, since the images will change in the data store, you need to ensure that incremental refresh is turned on. Then you should provide the list of labels against which you want to classify your images. Finally, provide the instructions to and ensure that enable ML assisted labeling is turned off, since the requirement states that all labeling should be done manually. It's difficult, I think, in that one in particular, to get all of the ones correct and get them in the right order. We got them all correct, so we would be getting a lot of points for that. The right order, we would lose some points on it, but I wouldn't worry about that. I think it's less points around the order than it is for getting the right actions, because some of these, it's really like, you know, if this one was above this one, how significant would that be, you know? So, yeah, I think we we can be proud enough of our answers for this one. I tell you what, let's do one of these ones that always looks super boring to me. So these ones that have like a real bunch of, you know, code, I guess, in there, it's not really so much about how great are you at coding and how well do you remember the commands, although it's definitely helpful if you can remember what is a real command or what a particular command does. But often the clue is in the question. And so you tend to be looking for, are we seeing 100 records? Are we seeing something about January 2020? So what have we got?
I think we can eliminate the first option.
Yeah,
It has got 2019.
yes, exactly. Definitely that one's out. This one's 2020 and those dates
Also, the
are
fourth option can be eliminated. The fourth option.
Yeah, correct. So it's either this one or this one. And then what is the difference between these two?
It should be the third one. Oh, sorry, the second option, because it include boundary. The third one, but it includes everything in January. The second one doesn't include, and the question says for January 2020. So I'll choose the third one.
Yeah, I reckon.
Oh yes, I see the boundary thing. Yeah, that line is the difference. Include boundary equals false. And it says yeah, so include boundary, yes.
Let's see.
Oh no, what's this?
What? Why is that?
Oh look, but it doesn't include the boundary, and so in fact that would be all of January 2020 if it didn't include the boundary.
Yeah, but you know, because we didn't look at it very well. It could have been. Oh my.
Yeah, I think that command needs to be in there. It needs to say include boundary equals false or equals true, probably, and that's why.
But the fact that they've shifted the date in the first one, you know, they started from, I think that's why.
It's a trick, but
That's
yes.
a trick, yeah.
So the two we should have ruled out were the two that didn't have the include boundary thing. So we should have ruled out these two, and then we should have looked at these two and picked that one. So let's see whether that's what it says. What? Oh yeah, yeah. Yeah, not specifying. So the include boundary command needs to be in there. That is our flaw. So
also I think we've gone on.
a different type of question, but it's not showing me anything different. Maybe we'll just pick one of these. Okay, this is a pick two. You complete training a linear regression model using Azure Machine Learning Studio. You want to test the model by having users of your organization call an endpoint. The outcomes of the model should be provided in real time for users. All workload will be CPU based. You need to determine a deployment target resource that can be used for testing and debugging while incurring minimal cost. So there is one of these that in all of the learning paths, it will have that phrase, includes minimal cost, so is the cheapest option. The other clue would be that the workload is CPU based. One of these, at least one of these, needs GPU to run. So if you know which is the cheapest one and which one uses CPU, then you know which is the right answer. Does anyone know which is the right answer? I wish I could tell you that I remember. So we'll just guess one. Oh, damn, I was supposed to pick two. And here is the lesson for you. Even though I said out loud before we started this question, pick two, I only picked one. And I should have picked two. So in that case, I would have got points for this, but I would have not got all of the points that I could have for this question. So yes, always, always double check you have the right number of answers. Local web service and Azure Container Instances, both are low cost and can be used for testing and debugging CPU-based workloads. AKS is used for production workloads, so this is Kubernetes. It's fast and it auto scales, and it's fancy compared to those other two. So it's not suitable in this instance for testing and debugging because that is going to be much more expensive. And Azure Machine Learning Compute Clusters are suitable for batch inference pipelines. So those are the keywords that you want to hook together. If it has batch inference pipelines, then it wants you to say machine learning compute clusters. But the service needs to be deployed as a real-time service. Understanding which ones need to be deployed as real-time services as well is also something that might come up. Okay, one more question, and I think it will probably be the last one in the group. Let's do this, drag and drop. So we have these three answers. We can drag them into these four boxes. Each one of these can be used once, 0 times, or multiple times, or not at all. So if we want to tune hyperparameters using Azure Machine Learning Designer, we would use put that one there for sure. Apache Spark, I'm going to put that one because HD stands for Hadoop, Apache. Autoscale instances for models based on compute requirements. So that one. This first one. Any guesses? Anyone else?
I'm gonna guess Insight because just try to find the hyperparameter. Yeah.
Okay, so what did we get right?
Oh no.
Not the first one. The second one's good. Third one's good. Fourth one's good. So I'll guess. But this is fine because we would have got these three correct and we only would have got one incorrect. And the explanation for that one is you should use Azure Machine Learning Compute Cluster to tune hyperparameters using Azure Machine Learning Designer. This is the only training target supported by Azure Machine Learning Designer as automated machine learning jobs running hyperparameter tuning. I think it told us that before, that Azure Machine Learning Compute Cluster is the only one supported for Azure Machine Learning Designer. I think it told us that in an earlier question. So we must try harder to remember that. Okay, let's try another group. BP 100. And now run experiments and train models. Oops. Okay. We're always going to start with one of these, and we can't go back and review them. So, Python scripts named sample.py in your local folder. The script trains a model using an sklearn library, and the script and training data are located in the same folder. You create a cluster named train compute. You plan to run the script in your local machine targeting the compute cluster you created. In your script, you define a local variable named compute _cluster, which is set to reference the train compute instance in Azure. You have a parameter named local _ folder that points to the folder where the scripts are stored. You need to run the code in sample.py. Solution: execute the following code to run the scikit-learn estimator. Does this work? Yes or no?
I think it's a yes.
I would bet yes too. Sarada?
Yeah, no idea.
No idea. And we say yes, because literally it's as simple as identifying the scikit-learn estimator runs from sklearn. If we look at question 2, you see what it's offering us there is it's asking us to import TensorFlow and do all of this stuff, and it doesn't mention the sklearn thing at all. So the code makes it look like it is a more complicated question than it is. But in fact, what it's really asking you is, I want you to use sklearn. Have they used it in that code? And the third one, they're using PyTorch, not sklearn. So again, the answer no. So that one is much easier than it looks like. They try to distract you with the code. Do not let them trick you. We do another one. Okay, you need to submit a pipeline run that has the following requirements: continuous execution even if a step in the pipeline fails, create outputs on all steps again for every run, even if outputs are not stale, pass a parameter named param1 with a value of value1 to the pipeline, not refer to any other run ID. So, is this one doing that or not?
I think it's a no.
I think so too. Because of this? Is this why you think no? I think no, because it's referring to parent one ID 3, and it said don't refer to any others. I think. Script passes parent one ID, and you need to run a script that does not refer to any other one ID. So not just did we get it right, but we had the right reason. Okay, what about this one?
I think it's a yes.
Yeah. Yes. Because the things that it mentions in there are the things that it mentions up here. And it has got a continue execution even if a step in the pipeline fails. So continue one step failure equals true. Those would be my, and then this one.
No.
And why do we think no?
Because the other the other line from the bottom was gone.
Which one?
Line 3 was gone.
What did line 3 do?
It disappeared.
I mean, what was it doing that is it doing one of these other things? Is it doing this? Create the outputs for all the steps? Is that what it was?
Yeah, it was.
Okay.
I thought about this correctly, yeah.
We generate outputs parameter. Yeah, cool, perfect. See how well we're doing. Okay, let me go through a few. Get like a bit higher up because I always answer all the ones at the start. Okay. You published an Azure machine learning pipeline to predict which customers should be targeted for marketing a new service offering. New customer information has been collected by a survey and you need to tune your model using this data. What should you do? Create a new training pipeline, specify a new data set, reuse the pipeline, change the data set and parameters, change the pipeline concurrency parameters to 2, convert the training pipeline into a real-time inference pipeline. What do you?
Option 3 might not be true. Option 1 would not be true either.
Shall we do 2 then? See, ruling things out definitely works. So you should reuse the pipeline and change the data set and the parameters. Azure machine learning pipelines are workflows that represent a series of machine learning tasks. Pipeline tasks can be executed independently from the underlying data, and you can register new data sets for each pipeline run. If necessary, in this scenario, as you already have a functional prediction model, you only want to tune the model using new data, you should reuse the pipeline. So this is good. So we shouldn't create a new pipeline and specify a new data set. The same pipeline can be used to train multiple models. And one of the benefits of defining machine learning pipeline is its reusability. You would create a new pipeline if the required machine learning workflow had changed and you didn't want to modify the existing workflow. Now, we wouldn't convert it into a real-time inference pipeline. This is known as model scoring. And we wouldn't change the concurrency to 2. Pipeline concurrency allows you to specify a maximum number of concurrent pipeline runs. Any runs above the concurrency limit are queued until new space is freed. So not really what we were thinking about. Cool. Well, it's a nice easy one then, hey? Which one's this? This is scikit-learn, and so this is sklearn. Well, now super easy, just take them and go, don't overthink them. Okay, we want to pick 2 actions here. Which 2 do we want? Well, I suppose definitely we want this one. And I suppose that because we are using Azure Machine Learning Studio to create a drag and drop designer pipeline. And this is the only one where we're dragging something. Any other guesses? I don't know. I think I would guess that. And that using Azure Machine Learning Studio, I just want it to be super easy. And where you're designing custom stuff, that seems more complex. And that sounds complex, regardless. Anyone want to fight with me? If it was that one. Okay. Drag and drop, no arguments. The last one though. You should also add the run.log table method to the code editor. Azure Machine Learning allows you to track multiple metrics with your experiments. These metrics are stored in the experiments run record for later retrieval and analysis, and you can use the run.log table method to log a dictionary object to the run. A dictionary is sometimes referred to as an array, and this allows you to store the key values with the associated data. I don't know that I would have been able to guess that without knowing it. So maybe I'll just give you that link as well in the chat. So this is a kind of multiple choice one. So you have a choice here in your drop down things. So you have to choose for the top one, RGB array values. Do we want run.log brackets, or do we want run.log underscore list brackets? And for the second one, so that would be image, surely. List, maybe? Does anyone think I've picked the wrong ones? picked good. Okay. And these are the reasons. Unlog list method to log an array of RGB values to the run record. Yeah, well, so I did not know those things, but I guessed them based on my choices. So that was an array, therefore I picked list. And that was said image there, I picked image instead of file. And my guesses were smart enough to be correct. So yes, even if you don't know what the meanings are, definitely make your best guess. You design and log a monitoring solution for a Linux-based Azure HD Insight solution that's used to analyze large volumes of data. Various operations will execute continuously on the cluster. You need the logging solution to be able to monitor the performance of the cluster. You want to minimize the configuration effort associated with implementing the monitoring solution. Which one do we want? So when it says you want to minimize the configuration effort, then I would say you want to rule out the .NET SDK one, because that is surely all code. Would we pick this one? Is Apache and HD and Hadoop linked? Yes. So that I was just thinking, you know, HD Insights, that's Spark, that's Apache, isn't it? And Apache Hadoop. Yeah. And I think that's the trick one, because that one requires a lot of work. The effort associated would be higher. So yeah, once again, ruling out what's what. So you need to know what each of these things are and what they do. Well, actually, I didn't know what that is. I know what these other ones are and was able to rule them out based on some small amounts of facts. So yes, logic once again wins. Okay, 2 actions on this one. So I want to use Azure Machine Learning SDK to create an automated machine learning pipeline. Your source data consists of salary information and some values may be missing. You need to ensure the pipeline can load your data and run without errors. Which 2 actions? So I would think we want to pick either tabular data set or file data set. Otherwise they why are they even there? So which one of those do we want? Tabular, right? This one? Anyone have any other thoughts? Okay, so yeah. Tabular and set the featureization experiment parameter to auto. Automated machine learning requires that input data be stored in tabular form, and you create a tabular data set to reference tabular data, such as found in CSV files. Yeah, if the feature parameter is set to auto, then input data will automatically be pre-processed and missing values will be handled. So yeah, those other things, you know, like we disregarded this because we were picking this, disregarded this because it's like, what is that even got to do with anything? And this because, well, I mean, it might have been that, but it totally wasn't, in that it didn't solve a problem. Like it would, like logging information is interesting, but it wouldn't solve the problem for us. It would just record it. So you can totally logic that one out as well. Okay, 3 actions in the right order. Azure Machine Learning, to create a machine learning pipeline, you need to ensure that files can be passed between pipeline steps using a named data store. Which 3 actions should you perform in sequence? So Azure Machine Learning, to create a machine learning pipeline, ensure that files can be passed between pipeline steps using a named data store. I guess.
Register a new Azure storage file container data store may be next. And the last one might be,
I would put it first and then that one, because you need to have the data store before you can point to it, I think. And then the last one,
specify pipeline data object for data output.
perfect. Look at us. We are doing so well. I feel like we are doing better today than yesterday. And I always tell people that I find the AI engineer questions much easier than the data science ones. And see how well we're doing today. Just applying our brains. Okay, drop down one. So you plan to monitor and debug pipelines by routing Azure Machine Learning logs to Azure Application Insights using the Open Sensors Python library. You have several query requirements and need to add fields to a custom dictionary to meet each of them. Which fields should you add in each case? So to differentiate between training and scoring runs, one type. Focus on a specific issue. Step ID. View logs for all steps over time. An ID. Yes. So those ones are all like pretty easy to guess, even if you don't know anything, I guess. So differentiate between training and scoring ones. Well, what is the run type? Is it training or is it scoring? focus on a specific issue. So if something goes wrong, at what step did it go wrong? And view logs for all steps over time is the parent run ID. So then we'll see everything. So not at all difficult, that one. Okay, yes or no question. You have the following code that creates a schedule. You're trying to understand the schedule configuration. For each of the following statements, select yes if it's true, otherwise no. So the pipeline is scheduled to run on a time interval.
The first one might be yes.
Why? Where do you see something? Is it the schedule? Polling interval 5. Maybe. Okay. Every time the data in the data store changes, the Hello World experiment is executed. No?
No.
The Hello World experiment will be executed at a polling interval of 5 minutes.
Yes.
Maybe. Oh no, we're like completely wrong on every question. Oh no. So let's see, the pipeline is not scheduled to run on a time interview. Schedule.create configures the runs dependent on the data store changes, not based on the fixed time interval. Well, how could we guess that? Every time the data in the data, yeah, I mean, obviously, once you know that, you know this. And then not executed on a polling interval of 5 minutes. Polling interval configures the frequency at which the data store is checked for any changes. Well, this really requires us to know that the schedule thing is not time related, but is related to changes. Yeah, I don't think we could have guessed that. Well, we couldn't have because we guessed wrong. Oops. Okay, anyway, we're not doing this one. We are going to the next section. Oh, no. That's super annoying. Once it logs out, it means I have to go back in from this page. Okay, optimize and manage models. Okay. Once again, this type of question, I wish they would put them at the end of the exam, not at the start, because you can't go back to these ones. However, let's give it our best go. You want to use interpretability package to explain machine learning models and predictions in Python. You run the following code to install the interpretability package on your personal machine. Okay. Then we train a sample model in a local Jupyter notebook, and you want to call the explainer locally. you need to write the code to call SHAP explainers and leverage the most appropriate one for the data set you are running machine learning on. Solution, you run the following code to initialize an explainer object and pass your model and some training data. I'm going to say no, because it doesn't call the SHAP explainer, it calls the tabular explainer. Oh, but it's yes. Oh, tabular explainer is one of the 3 SHAP explainers. Suada, tell me, did you know that one?
No, I was expecting, yeah, I had the same guess.
Good. I'm glad you didn't know it. I feel, though, particularly bad that I don't know it because Gia and I did a session on explainer models for DDD last year, and I should have memorized all of these things. Okay, let's memorize them now, though. So SHAP explainers, tree explainer, deep explainer, kernel explainer. That doesn't tell us. Tabular explainer calls one of the 3 SHAP explainers. Oh, really, you need to know that. Hang on, let's get both of those links and put those in there. Put those in the chat for you. And I would say that, yes, if you look up the DDD on YouTube or you look at my YouTube channel, I do have a session on there where I'm talking about explainer models, although in truth, I do talk a lot more about the story around it and the theory than I do about the particular explainers. Okay, let's have another crack. So, mimic explainer. Does this meet the goal? So I want to say no because now I don't even remember what I just read on the other ones. Is it no?
No.
I think it's no.
Yes, it is no. Mimic explainer does not select one of the SHAP explainers. You have to explicitly pass the model in the initialization process for this explainer. Good. And PFI explainer. I don't know, my brain just like freezes up and thinks, I don't know. That isn't even giving us the correct answer. I mean, it should say PFI explainer in there, not mimic. So even the tool is confused. Okay. So we do need to know about algorithms though. So if you're creating an AML, automated machine learning experiment to evaluate a regression model, you plan to export your AML generated model into an open neural network exchange, ONNX. You need to choose algorithms that can be used by AutoML models and support exporting to ONNX models. Which 2 of these do that? So really, it is literally something you know or you don't know. Anyone know? Anyone want to guess?
Decision tree.
And one more.
Nina SVC.
See,
Yeah,
when you
I was going to say that if decision tree is correct, then the other logical option will be a random forest.
that's what I thought too. When you said tree, I thought forest, because you know, tree, forest. AutoArima is only suited for time series forecasting, and it cannot be used in ONNX models, and linear SVC is for classification models, but data classification problems. So yes, you need to know, apparently. Because I'm not sure whether our guesses around forests and trees would have been enough. Let's get those links as well. So yeah, you should copy those links out of the chat, because I don't think the chat doesn't show in the recording. So even if you watch recording afterwards, you won't get the links. Okay, well, we would have got half the points for that, so let's not be sad.
That's okay.
We're looking for a different type of question. Okay, this one's interesting. You're working on Azure Machine Learning experiment that will perform image classification. You need to conserve resources by terminating the lowest 25% performing ones. What should you do? So you definitely do need to know what is Bayesian sampling, what is a medium stopping policy, what is a bandit policy, and what is truncation selection.
I think it's bounded policy.
You think bandit? But it is configure truncation selection. So truncation selection policy is an early termination policy that cancels a percentage of lowest performing ones, and each one's performance is evaluated using a primary metric. And the percentage of jobs to cancel is specified when you define the policy. As part of its calculations, the truncation selection policy considers previous performance with runs with less runtime. The bandit policy allows you to create an early termination policy, which will terminate training jobs that are not likely to result in an accurate machine learning model. So as part of the bandit configuration, you can define the amount of slack time between best performing job and the job being evaluated. So bandit is picking off the weakest ones, but not weakest in terms of lowest performing, weakest in terms of not likely to perform at all. So
Confusing.
You were close though, right? Your understanding was not far off.
Because I was
Medium.
thinking the truncation would be for like neural nets. If you are doing early stopping to avoid overfitting or something like that.
And it's like it is like that. It is early stopping, but of the ones that aren't going to work at all really. Well, the medium one calculates running averages and cancels any ones whose performance falls below the medium, so close to 50%, but it might not be 50%, of course, the median. You should not configure Bayesian. The sampling method selects hyperparameters based on performance of previous runs. So the Bayesian sampling method does not support early termination. Okay. So Bayesian hyperparameters, bandit's failure, median, and truncation is yeah, you can truncate a 25% mark or 50% or whatever it is that you decide. Cool. Oh, there's another one on that. Shall we try that? You tune hyperparameters for your hyperdrive experiment based on random sampling. You want to terminate 30% of the lowest performing runs at each evaluation interview based on the performance of the primary metric. So should that not again be? Should it not? Oh, that is confusing. Because I'm thinking, is it not then that again? Because
Yeah, very similar.
yeah. Yes, it is that one again. Good. How I have explained it in my brain makes sense to myself. That's always reassuring. Oh, yeah, let's have that one. So use Azure Machine Learning as part of a project that will evaluate a black box machine learning model. You need to ensure that the mimic explainer interpretability technique can be used to evaluate the black box model. What should you do first?
Create a multi-label image classification project.
Well, I think I would have trained a global surrogate model. Anyone else want to pick a different one? Oh, you see? So it is train a global surrogate model. And this is meant to be an interpretable approximation of the black box model. Black box models are those for which no explanation exists, and which means that the public does not know how the model makes its predictions. Once a surrogate model is trained, the mimic explainer interpretability technique can be used to interpret the model. You should not create a multi-label classification project. Multi-label projects are used when multiple labels might be applied to a single image. For example, if an image included a dog or cat, it might receive a label for each dog or cat. It's not really got anything to do with what we were doing here. The reason why I was pretty sure it was this one is because the talk that Gia and I did on explainer models, I talked about the Hitchhiker's Guide to the Galaxy. Have you all seen, read, or listened to the Hitchhiker's Guide to the Galaxy?
No, no.
Oh, it is a cult classic. When I was young, I listened to it as a radio show. I think there have been 2 movies of it in the time that I've grown up, and I think there is also a series on maybe Amazon Prime. It is absolutely a cult classic, but what it is it starts with, well, no, it doesn't. Let's not go where it starts. But there is a civilization in the future which is super advanced from ours, and they have built the best computer in the entire universe. And on the day that is the big launch for this beautiful computer, the 2 people who have been chosen stand in front of it and they ask it the question. They ask it a question. And the question they ask is, what is the answer to the ultimate question? And the computer goes off for like a really long time. And then eventually it comes back. I mean, like thousands of years later, it comes back with the answer 42. And then the people who are there to receive the answer 42 are furious because they're like, 42, like, what does that even mean? What is the question? And of course, they hadn't asked a very clear question. They had said, what is the answer to the ultimate question? What is the answer to life, the universe, and everything. And it had come back with 42. And so when it came back with 42, and they then had to ask it, what is the question? This is explainer models and black boxes in action. So, you know, that computer was a black box. They'd asked it to spit out a result. It spit one out, but with no explanation as to how it had come to that answer or what that answer meant. In order to then get the question, they needed to train a global surrogate model. So they created another computer that could then go off and investigate all of the questions to which 42 would be the answer, which is essentially how you sort of go backwards to find out what is the algorithm that the computer used, or in that case, what is the question? What is the real question to life, the universe, and everything? So you will often see the number 42 referenced in things. This is where it comes from, and this is what it means. And you should all take it as a priority
I
to
see,
like
yeah.
watch the film, read the book, or listen to the
I've been
lectures.
wondering, you know, when we are like doing sampling, they put the random number 42, random 40 equals 42. I'll be like, why is it always 42 that people are choosing?
Yeah, because it's the answer to life, the universe, and everything. Definitely. I say read the book. I think the book is really good. The movies, it's yeah, I can't really speak to it because I read the book first, and whenever I read the book, I prefer the book. And if I watched the movie first, I might have preferred the movie. But it's a cult classic. Definitely watch that. Okay. Let's find another. Okay. Drop down question. You're preparing to register multiple trained models using Azure Machine Learning. You need to identify the most appropriate compute targets that will be used for each model. Which deployment target should you implement based on each model usage scenario? Okay, so batch inference. Do we want Kubernetes?
I'll use a zero machine learning computer instance
The bottom
for
one.
batch. Yeah, the bottom one.
Okay. Real-time inference.
I'll use AKS.
And testing and debugging.
Yeah, that's the cluster.
The batch inference is the cluster.
Oh, I
And
see. Yeah.
testing and debugging is the
Instance. Okay, yeah, instance. Yeah, that's true.
Okay. So those ones we just need to remember. Definitely there is a lot of stuff around what would you use for which and all of that.
Yeah. Trying to build an instance, yeah. I missed it up.
Get those two links as well. Oh, let's not have that link because that one's not working. So we'll have that. Okay, yes or no's. You register an Azure machine learning model. You enable model data collection to collect data from your AKS deployment of the model. And you see data being collected in model data blob container. You write the following script. For each of the following statements about drift configuration in code, select yes if the statement is true, otherwise select no.
The first statement would be no. The second one would be yes. The second statement. And the third statement would be yes as well.
Ah, apparently they, oh, no. Okay, so the first one is yes. The second one, yes, is yes. And the third one is no. Why is that? Drift detector would send an email if the drift coefficient is 0.4 when evaluated. Drift threshold is configured to be 0.3 in the data drift detector create method. The configuration along with the alert config parameter ensures that when a drift coefficient of 0.3 or higher is detected, an email is triggered. A drift coefficient of 0 indicates no drift and 1 maximum drift. I don't know what that means. Second one, we were right. The first run of drift detection will not execute on an existing compute cluster based on your parameter setting. For data drift run methods has parameter create compute target set to true. Setting the value to true creates a new compute cluster for the execution of the run. Okay. Okay. So the fact that it is existing means it would not run on there. It would only run on the new version. That was harder. One as well. Okay, you have a real-time inference pipeline as shown in the exhibit. The pipeline takes comma-separated features related to an automobile and predicts its price. You need to test the pipeline with minimal costs and effort against some test data, which is located in a text file on your machine. Which module should you use? Export, import, join, or enter data manually. Now, for fundamentals ones, I always say whether you look at the exhibit or not makes no difference to your ability to answer the question. I would say that's not necessarily the case on the associate level exams. You might need it. But you can't see the exhibit and the question at the same time, which I find annoying.
Join data would be the one, I think. We should enter data manually. It provides a way to copy and paste the data from your text file to the module and feeds it to the select columns in the dataset module. Should not use join data module. Join data module is used to combine data from multiple data sources. This module cannot be used to feed input data from a single source. Shouldn't use import data because that allows you to import data from a data source, such as storage accounts, data lakes, SQL, etc. Since your data is in a file on your local machine, using this module will add additional steps to create a storage in the cloud and upload the file, and will also increase the cost, and obviously not export. Okay, so the clues were the minimal costs and effort, and that it was located on a text file in our machine. So yeah, in fact, the exhibit really doesn't share anything with us that we need to know. Those clues were all in that second sentence there. Okay, the team creates an automobile prediction pipeline as shown in the exhibit. You need to submit and run and understand the model. For each of the following statements, select yes if it's true, otherwise select no. The split data module splits the columns in your data set based on how you configure the module.
The first statement would be yes.
Are you sure?
Should be no. You should split rows. So
Split
you
rows.
set and test set.
Yeah.
Yeah, that's true. Rows, not columns. Yeah.
Model classifies automobiles into various price categories.
Second statement would be yes.
You put linear model right there, right? The exhibit. Linear regression, no, it cannot be classification. I don't think so. No, linear, I think no.
The third
Yes.
one is no.
Score model. Generate scores. I would say yes. I don't know.
Yes, so we are good. As long as they let us all into the exam together, we would pass. Yeah, so we split rows, we don't split columns. Linear regression runs a regression algorithm, so it doesn't run classification. And score model takes the input and uses the test data from the split data module. Cool. There is a nice little tutorial there if you want to try it. Because often, if you try something, it fixes in your mind what it looks like better. Okay, finishing this one, and we're going to the final section. I'm so on track. Normally, I am really behind and I don't have enough time for the final module. Deploy and consume models. Okay, you want to deploy your trained model to a production environment. You want to ensure that once the web service endpoints are deployed, only authorized users are able to reach the service using the token auth method. You decide to use AKS to deploy your model. You need to write the script so that when it's executed, the token auth method is enabled. Solution, execute AKS web service deploy configuration. Does this solution meet the goal?
I reckon yes. Yay.
Execute AKS web deploy configuration auth enabled equals true. Shall I say no then? And then the third one. Oh, yes. There we go. It's very easy when the first one is the correct one. Although in the exam, you won't know. So all three of them, it doesn't help you. It doesn't help you when you can't see the answers. Okay, do we know what these are? You plan to create a compute environment for your image classification deep learning model, leveraging compute unified device architecture, so CUDA computations. You plan to use data science virtual machine for this purpose. You need to configure your VM to support CUDA. What series should you configure your VM size?
I'll choose DSV2.
I reckon option 3 as well.
Oh.
Oh. You and I would both be wrong because I would have picked that as my guess as well. Okay, so NCV2. In order for your model to run image classification, deep learning model, leveraging CUDA, you need to configure the VM that provides support for GPUs. So this one is general purpose. So the DSV2 is general purpose, doesn't support GPUs. F series doesn't support GPUs. And so it's good for hosting a few little databases, this one. Yeah, so you need to know which of these is for GPUs and which ones isn't. And I would guess, well, not guess, definitely there is stuff in the learning path about CUDA and which one is suitable. Probably none of us are using that unless we are researchers working for a research organization. Let's get those two links out. Okay, so you use Azure Machine Learning Studio to manage compute targets. You need to deploy the appropriate compute target for different machine learning tasks. Which one should you use? To deploy trained models to provide real-time predictive services at scale. Attached compute clusters, or inference clusters?
Deploy inference clusters to deploy. Yeah, I think so. Yeah. Support scalable, low priority.
Scalable on-demand processing using low priority virtual machines.
Attached.
And Databricks clusters.
Last one leads with compute clusters.
Now remember, we don't need to have one for each. We could use them, we can use them more than once, not at all of that. So it doesn't necessarily, like, don't just choose that one because you think it's the only one left. However, let's just see. Inference. Second one is compute. Third one is attached. So we get the first one correct, but not these two. Databricks attached. Scalable low priority is compute clusters. Yeah. So really there is a lot of stuff in the learning paths around what can be used for what and what should be used for what. It is definitely worth investing time memorizing that. And it is such a stupid thing to memorize for an exam, I think, because in real life, when you are doing it, you would surely look and see what is available at the time and what does the latest documentation tell you. As they are always creating more and more powerful machines all the time and bringing down pricing on other ones. I don't know. It seems to me like these are weird things to remember. But for the exam, it is definitely worth investing some time in remembering them. Okay, you use Azure Machine Learning to create a machine learning model. You plan to deploy the model as a real-time web service using your local system. You need to configure deployment settings. Which two actions do we want?
The first one will be set auth enable to true in your deployment configuration.
I think we would need a Docker.
You don't think this one?
Yeah, because it's going to be on the local system. I'm assuming that's a local machine. And we need to use the Azure machine learning environment. So we need to be able to ship everything together. And that's just my understanding, yeah. To make that environment available on our local machine, we need to be able to put in a Docker to do that, something like that.
Okay, so
Good
on the Docker. Good on the Docker, but it's not the bottom one, it's the service endpoint. Yeah, I think.
Yes, specified.
So you install Docker on your local machine to specify the service endpoint where requests will be accepted. To deploy a model as a real-time web service using your local system, you must install Docker. Docker is the container creation and management platform that can be deployed to a variety of operating systems. Okay, well, there we go. So, working as a team, we would have got one right. I think if I was doing it, I might have got one right as well, but I think I probably would have picked these two. So I probably would have got that one right. Ugh. more study required before I redo this one. We knew that cert. Okay. You use Azure Machine Learning to create machine learning models. You plan to deploy your models as web services using various compute targets. You need to ensure each deployment is configured to require authentication. Based on compute target, which authentication method would you configure? So for Azure Container instances, we would use
Key authentication. Sorry, no. Key token authentication.
and for AKS.
Key authentication only.
We have no security experts amongst us. Yes. So you should, for ACI, you should use key authentication only. ACI allows you to package and deploy your machine learning models using easy to manage containers. And a container is a virtualized app that includes the resources it needs to run, including file, dependencies, services. It only supports key authentication. And you should configure key or token for Kubernetes. Kubernetes supports highly scalable compute options from Azure Machine Learning Experiments, in addition to supporting multiple node clusters. AKS can be used for experiments that require hardware acceleration via GPU or FPGA. Finally, AKS can dynamically scale compute availability based on workload. Well, that doesn't tell us anything about the tokens, but apparently AKS is good with the tokens. Okay. More actions for this one? Yeah, my brain is definitely giving up too.
Create a real-time inference pipeline. That's it.
Okay, so pick the right ones, not in the right order at all. So this is the order. Okay, so pipeline before cluster, and then deploy the endpoint and then test the endpoint. It does have a little tutorial you can practice. Okay, 3 of these and in the right order. Batch inference. Pipeline endpoint has been scanned for vulnerabilities. You want to test some changes, ensure the existing pipeline is not modified, ensure the pipeline endpoint is not changed.
Creating a new pipeline that implements your changes will come first.
Which one? Oh, this
Creating a
one.
new pipeline. Include the test pipeline version in your REST calls will come next. And publish the pipeline to your scanned endpoint.
So remember from the previous question, we have to publish the pipeline first before we test the pipeline. So all 3 were correct. So you would get the points, but then they were not in the right order. So you would not get maximum points for the question. However, if we fix that in our brains, publish the pipeline before we test the pipeline, testing always last with the pipeline, then we should be fine. There are no interesting questions. This is my problem in the exam. I start to get really bored and I want to walk out, but I didn't in the exam and I did pass it. So yes, don't give up is the lesson. You have to keep going. Okay, what about this one? You use Azure Machine Learning to create and publish a batch inference pipeline. Your pipeline is used by automated processes. You need to ensure these processes can authenticate to your service automatically. What should you do?
I think it would be supply workspace subscription and resource group information to the workspace constructor.
It was not. You should create a service principal, grant access to your workplace, and configure service principal authentication. Service principal authentication can be used in scenarios where prompting a user for credentials is not feasible, such as when automated processes need to interact with a published pipeline. A service principal is any directory object that can be used for authentication. User accounts are considered service principals. Use Azure Machine Learning Designer to create a batch inference pipeline, and you can plan to publish the pipeline using a web service. You need to ensure the pipeline can make predictions on the new data supplied at runtime. Which should you do?
Connect a different data set to the pipeline.
Is it published the pipeline to the new endpoint?
It's neither of those. It's create a parameter for your data set. Create a parameter for your dataset. This option allows consumers to provide a dataset for your pipeline at runtime. This is useful in scenarios where the model is trained on a dataset, but is used to formulate predictions on new data. You can parameterize a pipeline by using the dataset module. Create a parameter for your dataset. That sounds pretty handy. Remember that one, because that does sound pretty handy. Use Azure Machine Learning to deploy a machine learning model for Kubernetes, a Kubernetes cluster. During testing, you receive a large number of HTTP 503 errors. You need to reduce the incidence of HTTP 503 errors. Which 3 actions should you perform?
The first action I should perform is migrate the service to an Azure Machine Learning Compute cluster. The second one, I think it would be increase the request timeout threshold.
I think I would pick those 3, but let's see. These middle 3, change the minimum number of replicas, change the utilization level, and modify the autoscale max replicas. Yeah, it is unlikely that the solution would be migrate from Kubernetes to Azure Machine Learning Compute. Like that's a big task. That's saying that everything you've done is wrong. But yeah, it was these middle 3. Change the minimum. Modify the autoscale. So change the utilization level at which containers autoscale up. Kubernetes clusters are designed for heavy real-time production workloads. One of the primary benefits of deploying to Kubernetes is its support for autoscaling. This means as a workload increases or decreases, a Kubernetes cluster can add or terminate cluster nodes. HTTP 503 service unavailable error indicates the service is operational, but it's unable to respond to requests. This often indicates that a server is overloaded and doesn't have the resources to process the request. So by default, it scales, AKS scales up when cluster utilization exceeds 70%. If there's a sudden increase in requests, the cluster might not be able to add nodes quickly enough to handle the requests. So by reducing this threshold, you allow the cluster to scale up under lighter loads. You can also modify the autoscale max parameters. By default, it can scale up to 10. By increasing this parameter, you can ensure that your cluster can handle a higher number of simultaneously requests. And you can also change the minimum number from 1 to more than 1 so that it's already big when it starts.
Cool. Okay. Well, I think that is enough for one day. So, yes, I hope you have enjoyed this as much as I have. I will share the link to the recording so that you can review a bit slower if you want to. As I say, don't share that link because, you know, I'm not really meant to be sharing these this private IP. So, you know, keep it to yourselves for study. I might put in some more of these sessions next week if I can find some time, so that we can, so that I can keep helping you learn. But I would say that in the meantime, you know, go back to your learning paths, and to, if you want extra, you can read those links that I've put in the chat. Otherwise, good luck with your exams, and let me know how you go. Yeah, cool.
Thanks, Michelle.
Thanks for joining me today, everyone.
Yeah. Bye.
Bye.
Bye-bye.
Thanks, Michelle, for letting me join. Bye.
Bye-bye.